Hey guys, welcome to your video lesson on solving linear systems by substitution. So in class today we did several examples where we graphed linear systems and found their point of intersection, and we ended up looking at one where we could do it algebraically. Now graphing is great if we have numbers that are really nice or small numbers that make graphing easy, but once we get into situations where our point of intersection maybe doesn't have integer or whole number values, but rather has decimal fraction values or very large numbers, solving algebraically is going to be a lot easier, and we won't be estimating using graphs. So for the first one here, we need to solve this linear system by substitution. We're provided with two equations. So the first one is 2x plus y equals 7, and the second linear equation is y equals x plus 1. In order to solve a linear system using substitution, we must have one of our equations already isolated for either the x or the y value. So you'll see our second equation here is already written in y equals form. It can also be rearranged to have x by itself as well, and that would allow us to use substitution, which we can see in a further example when we get to example number 2. So to start off with, step 1, we're going to start by labeling each equation, calling them number 1 and number 2. So I'm just going to call the first one number 1 and the second one number 2. It doesn't really matter which is which, but it just helps us walk through the steps of this problem. So for step 2, we are going to substitute the rearranged equation into the other equation. So our second equation is the one that is in y equals form. So we're going to substitute equation 2 into equation number 1, replacing that variable. So instead of y in that second equation, second being the one we're substituting into, we're going to replace it with this expression. So we're going to write 2x plus, instead of y, we're going to substitute x plus 1 and make it equal to 7. Step number 3, solve the equation for the variable remaining. So in this case, we're solving for x. I put this in brackets here because sometimes there may be a coefficient in front of your y term, in which case distributive law would be applicable. Since it's just a plus 1 out here, we don't have to worry about that. We can drop those brackets and collect our like terms. So 2x plus 1x is 3x. We've got that plus 1 equals 7, and just keep continuing on here, solving your equation and dividing both sides by 3. What that provides us with is the first half of our point of intersection. So we know that x is equal to 2. We still need to find the y value. So to get the second half of our point of intersection, we're going to substitute x equals 2 into either of the original equations. It doesn't matter which one you pick. So in this case, I'll just pick the second one here, y equals x plus 1. So into equation 2, and we're going to solve for y. So y equals x plus 1 is our equation. We're now going to substitute that first value we solved for, and we get y equals 3. When I'm normally solving problems like this and it's not on a paper that's quite so guided, I like to circle those pieces as I find them so they don't get lost in all my work. Step 6, state your final answer as a coordinate. So my final answer is 2, 3, which is the solution to this linear system. Nice thing with linear systems is we can always check our work. So the way to do that, you have to check your work by completing a left side, right side check, and you have to substitute your xy solution into the original equation that you did not use in step 5. So in step 5, I used y equals x plus 1. For my check, I'm going to scroll back up here. I can't use this equation because I've already used it. I have to use this first one. So 2x plus y equals 7. So to set up my check, 2x plus y is on the left-hand side. 7 is on the right-hand side of my equation. So you'll see here there's no math to do. This side I'm going to substitute my numbers in. So x is 2, y is 3. Just do my BEDMAS math, so 4 plus 3. And the left-hand side I get 7. Right-hand side is also 7. If the left side and the right side are equal, we know that our answer is correct. So the point of intersection is 2, 3. Now let's move on to the second example. Alright, so for example 2 here, 2x plus 5y equals negative 18, x plus 2y equals negative 6. You'll notice that neither equation is rearranged into y equals mx plus b form, or neither one has a variable isolated. So when I look at this particular question, it's really easy to rearrange this and isolate for this x term here because there's a positive 1 in front of it. It's going to be a real simple rearrange. Also, if it has a negative 1, it's a pretty simple rearrange as well. So again, to start off, we're going to label the equation, number 1 and number 2. I need to isolate one of the equations for either the x or y variable. So I'm going to take equation number 2, and I'm going to isolate equation 2 for x, get the x by itself. So to do that, I have to get this 2y term over to the other side. Subtracting it over, I get negative 2y minus 6. And now I have that second equation rearranged so that I can substitute it. So now we're going to substitute the rearranged equation 2 into equation number 1. So grabbing our original equation, 2 times x plus 5y equals negative 18, and I'm going to grab this rearranged expression for x and substitute it in here. Next step is to solve this equation for x, or sorry, rather for y here. So we have to grab the 2, multiply it in using our distributive law. So 2 times negative 2 is negative 4y. 2 times negative 6. And continue on solving this equation. So we'll collect our like terms, negative 4 and positive 5. We get positive 1y minus 12. And get this negative 12 out of here, add it to the other side. So 1y is equal to negative 6. That gives us half of our answer. So remember, point of intersection is always both coordinates, x comma y. So just like we did in the previous one, you're going to take that y equals negative 6 and substitute it into one of the two equations from above. It's up to you which one you pick. So I'm going to come up here, and I'll just choose that second one. X plus 2y equals negative 6. It shouldn't matter which equation you pick. You should get the same answer. So x plus 2y equals negative 6. I'm going to substitute my y value into that equation. X minus 12 equals negative 6. And then to solve for x, you add the 12 on both sides, and you get positive 6. So my two key pieces, y is negative 6, x is 6. When you go to put it in here for your final answer, remember it's always x comma y. So in the previous example, we did find x first and y second. Make sure you get them in there in the right order. 6 comma negative 6. So a point of intersection is a coordinate, so we always write it with brackets and a comma in between. For the last step, we can do a left side, right side check to make sure we've done this correctly by choosing the other equation, so not the one I used up here in this step. So that equation, sliding up here, this one's already been used. 2x plus 5y equals negative 18. 2x plus 5y. On the right hand side, I have negative 18. Substitute in our numbers. X is 6. Y is negative 6. Multiply out, and using BEDMAS, add them together. And here we get left side is equal to the right side. Therefore, we know that our answer is correct. So our point of intersection is 6, negative 6. If you do get these incorrect, they're not matching, either you've done your work wrong or you've done your check wrong. Something along the line, you've made an error. So now if you flip to the next page, you're given a third example. And I'd like you to look back at your notes for the last two examples we completed together. Try to follow along with the steps and solve and find the point of intersection for these two line segments. And come back and check your answer. So pause the video now so you can try that out, and then I'll see you in a minute. All right, welcome back to the answer here. Hopefully you've had a chance to try it out and you didn't get too stuck. Your final answer you should have come up with was 1, 7 for your point of intersection. Now I've shown it here a few different ways because there are some options when you're doing these kinds of problems. So option 1 would be to rearrange the first equation. So if you rearrange this first equation for y, that 5x would be subtracted over to the other side, so we'd end up with that negative 5x plus 12. If you chose to rearrange the second equation, that's also fine. But what you'd want to do is get this negative y to the other side by adding it, thus having a positive y value, and then the negative 4 would come over to this left by adding it. So we end up getting a positive y and a positive 4 as well. So that's what that equation would look like if you chose to rearrange that second one. Keep in mind sometimes if there was a coefficient in the first one, you would want to choose that second one. So it's a good idea to know how to rearrange both positive y and negative y values. So you can see for this first one, I rearranged one, and then I substituted into second. For this one, I rearranged the second, so then I substituted it into the first. Either method you choose, though, we get the same answer. We get the same x value. Then for the second portion, there's two different ways you may have done this as well, just depending on what you felt like. Once you found that first x value, you could have chosen to substitute it into the first equation, like so, and gotten y equals 7, or you could have chosen to substitute into the second equation. And I decided to show you both just to show that no matter which equation you pick in this step, you do get that same answer. And then finally, your check step at the very end, you'll notice again they're different because whichever equation we chose for this portion to calculate that second variable, you cannot use that for your check or it won't give you a valid check. It might say it's the correct answer when it in fact is incorrect. So coming down here, you'll see I picked the opposite equation. I used equation 1 here, equation 2 for my check, whereas over here I used equation 2 to find that second value. So then I used equation 1 to do my left side, right side check. Okay, so feel free to flip back through the video here if you need to check your answers. And that's it for this video.